course off on Tuesday, we were talking about circles that are not centered at the origin. And we spent a long time talking about the formula for a circle and how it gets changed if a circle is not centered at the origin. And then we looked at working out what the coordinates at the center were and what the radius is, etc., etc. So today I want to just sort of kind of expand on that idea a little bit, and it's something that comes up quite often. What we were talking about the other day, let me just get rid of this in the middle of the screen. What we were talking about the other day, so when an equation is given, or an equation of a circle is given to you, and it's given to you in the form, let's highlight it here, x minus a squared plus y minus b squared equals r squared. As I had said the other day, in that form, this is referred to as center radius form. Okay, and the reason that it's called center radius form, if you recall, is because it's possible for us to read the coordinates at the center of the circle and for us to know the length of the radius. Okay, so for example, if we were given, like in example number 4 here, if we were given the equation of a circle, x minus 2 squared plus y plus 3 squared equals 64, we could come along and we could say the coordinates at the center are going to be positive 2 and negative 3 is the y coordinate. All right, well, this value over here is r squared. So if r squared is equal to 64, then it means r, the length of the radius, would be 8 in this case. Now, what we can do is we can multiply all of these brackets out. And when we do that and we make the equation equal to 0, the equation can be written in the form, and I'm just going to highlight this for you in a different color, can be written in the form ax squared plus bx plus cy squared plus dy plus e, okay, where e represents a constant, okay, and a and b and c and d are coefficients, all right? It's also important to note that when you're talking about a circle, the coefficient a and the coefficient c have to be the same, right, for it to be a circle. If a is different to c, then it's not a circle anymore, it's an ellipse or something else. But we don't deal with anything like that in the CAP syllabus. So going from center radius form to this form that I've highlighted in purple, general form, is very easy because all you're doing is multiplying out. So multiplying out is like what we do in grade 8 or grade 9. It's extremely easy. All right, so I'm just going to show you that very quickly, and then we're going to talk about the more important of the two, which is going back the other way. All right, so if they gave us a circle x minus 2 squared plus y plus 3 squared equals 64, and they asked us to write this in general form, this is what we would do. We'd multiply out our brackets. So remember, x minus 2 squared means x minus 2 times x minus 2. And y plus 3 means squared means y plus 3 times y plus 3. All right, we'll leave the 64 on the right-hand side for now. And then we're going to do FOIL. So this would give us x squared minus 4x plus 4, I've taken a shortcut there, plus y squared plus 6y plus 9. Now what I'm going to do is I'm going to bring the 64 over, change its sign, and now you can see I've equated the right-hand side to 0. So that letter E is going to be a combination of 3 different numbers. Okay, so E is going to be the 4 and the 9 and the negative 64 all combined. All right, so what's going to happen now is we just put them all together. So x squared minus 4x plus y squared plus 6y. All right, and now we've got 9 plus 4, which would give us 13. And if we had 13 and we took away 64, we'd end up with negative 51, if my maths is correct. Is that right? I think so. Okay. So very, very easy. And I highly doubt, to be honest with you, that they would probably ask you to be able to, ask you to do that. But it is important that you are able to, in case it does It does come up. All right, and again, if you have a look at your final answer, what we would say in this case, the value of A would be 1, B would be -4, C would be 1, D would be 6, and the value of E is -51. And again, very important, A and C need to have the same value, so in order for it to be a circle. All right, now, yes, Njabulo.
Ma'am, can I just see the general formula if you don't mind? I just want to write it down fast.
Okay, so the general form, there it is in the purple block for you. Ax squared plus bx plus cy squared plus dy plus e equals 0. That's general form. And the one in pink up at the top of the page, that's center radius form. Okay, can I continue? Is that okay?
Yes, ma'am. Thank you.
Okay. All right. Yes, Cassandra. Yeah. So you're expanding everything that's squared, and then you're collecting together the like terms, which are only the numbers, and then you basically just writing everything on one side of the equal sign and making it equal to 0. That's all it is, Cassandra. Okay, and then it's referred to as general form. Okay, that's very easy because for us in matric, okay, yeah. So for us in matric, multiplying brackets out is not difficult. The only thing that we sometimes forget when we're in matric is that when a bracket is squared, we forget that we have a middle term. So in other words, if I've got something like, let me choose a different thing, but let's say if I've got x plus 4 squared, it's a very, very common mistake. Very, very common mistake. You see matrics doing this. X squared plus 16. Okay, and it's not. All right, because it means x plus 4 times x plus 4. So you've got to do FOIL. Firsts, outers, inners, lasts. Okay, so there is a middle term, an x term that we must not forget about. Okay, and there is actually a shortcut to this as well. I don't know if you've been taught that. Normally it would be discussed with you when you were in grade 10. And what they would say to you is this, is you square the first term. So you square x and you get x squared. Then you multiply the terms together and double it. So 4 times x times 2 is 8x. And then you square the last term plus 16. And that gets you to the answer in one step instead of having to do FOIL. But not everybody is comfortable with that. Okay, but anyway, very important, wherever you're working in maths, don't forget, if you're squaring something, okay, it has to have a middle term. Unless of, yeah, it has to have a middle term. It absolutely has to have a middle term. Okay, yeah, square, double square, that's it. 100%, perfect, well done. All right, now, right, what we actually need to focus on here is not so much the removing of the brackets, but it's actually putting the brackets back in. So what they often expect us to be able to do, matrix, is that they will give us something in general form, and they will expect us to be able to rewrite that in center radius form. So now we're going from the blue to the yellow. Okay, so from the blue to the yellow. It's a little bit trickier, right? So this links back to something that you actually already know, because in grade 11, you used completing the square to rewrite y equals ax squared plus bx plus c in the form y equals ax plus p squared plus q. So in the case of the circle, you're also going to have to complete the square, but you have to do it twice, because you have to do it once for x and you also have to do it once for y. Okay, and it's not as difficult as completing the square in grade 11. I'm going to show you with this example that I'm going to do now exactly how that works. Okay, are there any questions so far? Can I just jump straight into this? Is everybody okay? Right, I shall take your silence as meaning that everything is fine, and if it's not, you will stop me. Okay, so in example number 5, they ask us to rewrite the equation x squared minus 6x plus y squared plus 4y minus 5 equals 0 in the form or center radius form. So this is what I like to do, okay? So I'm going to write down my x squared, and I'm going to write down my minus 6x, and then I'm going to leave a space. And then I'm going to write my plus y squared and my plus 4y, and I'm going to leave a space, and I'm going to write equals, and I'm going to take this 5 over to the other side, and I'm going to change its sign. Okay. Now I want to complete the square. So if you have been given something like x squared minus 6x, and they want you to complete the square, what you are doing is that you are taking half of the coefficient of x. So in this case, -6. That gives us -3. And we've got to take that number and we have to square it. We get 9. So what I'm going to do, Matrix, is I'm going to add 9 to the left-hand side so that x squared minus 6x plus 9 is a perfect square trinomial. Okay, and then I'm going to, so that's me completing the square for x. Now I'm going to complete the square for y. I'm going to do exactly the same thing, right? I'm going to take half of the coefficient of y, in this case it's 4, and that gives me 2. And I need to take that number and I need to square it, and that is what I've got to add next to that over there. Right. But this is an equation, guys. So if I add things onto the left-hand side, what I do to the left, I've got to do to the right as well. So I've got to add 9 to the right. And because I added 4 to the left, I've got to add 4 to the right-hand side as well. Okay, in order for the left-hand side and the right-hand side to be balanced. Okay, now I'm going to factorize my perfect square trinomial. So I've got a perfect square trinomial in terms of x and another perfect square trinomial in terms of y. Right, so now I'm going to factorize. X squared minus 6x plus 9 factorizes to x minus 3 multiplied by itself. And y squared plus 4y plus 4 factorizes to y plus 2 squared. And there on the right-hand side, I've got 5 plus 9 plus 4, which is going to leave me with 18. Okay, so what this method does is it allows me to establish a way of being given a circle, the equation of a circle, and if I don't know what the coordinates at the center are or what the radius is, then it allows me to determine this. That's why I would want to be able to use this. Okay, so if they gave me something in general form and they wanted to know the coordinates at the center or the length of the radius, I would have to complete the square on x and y in order to be able to answer that question. Is this making sense? Is there anything that I've said that you'd like to ask a question?
Ma'am, me, I don't understand the first part of this method.
Are you talking about?
Yes, where you add 9 and 4.
Okay, so what you're struggling with is the completing of the square. Is that right? I wonder if this will help. Okay, so what I'm going to try and do in Jabula is I'm going to try and draw you a picture to explain to you what it is that we are doing. Okay, and either this is going to be amazing or it's going to be absolutely dreadful. And I really, really, really hope that it's amazing and not dreadful. Let me just give myself a bit of space. Okay, so if I give you x squared minus 6x, all right, did you know that if you could draw this into a picture, that it would be a rectangle? Did you know that? Okay, and yeah, okay, so now look at this, all right? Okay, so this is your rectangle. Okay, let's just draw a rectangle here. And the reason that it's a rectangle is because if I factorize it and I take out the x, actually, you know what? A plus is a better one to use when we're working with distance. So let's take out the x, and inside brackets here, I'd have x plus 6, right? right? So if this side over here is x, this longer side up at the top is x plus 6. Does that make sense? Okay, and that gives me a rectangle. So the expression x squared plus 6x is rectangular in shape, right? Now what I want to do is I want to take this rectangle and I want to make it into a square. So if something is going to be square in shape, what does that mean? It means its sides have to be equal in length, isn't it?
Yes, ma'am.
They have to be equal in length. So this is what I'm going to do, all right? From here to say here, this is also x. Let me just give myself a little bit more space here. Just one second. Okay. So let's do that. Okay. That is x, and this is x plus 6. Right? So if x is a certain distance from here to here, then the same distance from here to here, I suppose it would be about that. And whatever's left, this bit over here is going to be the bit that I'm coloring in pink, is going to be the bit that is 6. Okay, so the pink part is the 6 and the orange bit is the x. What I'm going to do is I'm going to cut it in half. Okay, so now I have something that is 3 units long, something that is 3 units long, and another thing that is 3 units long. Okay, and now what I'm going to do is I'm going to take this block over here that I've just put the pink circle in, and I'm going to move it. Okay, remember, it's got to line up with this one over here. So what I'm going to do is I'm going to take this pink side over here, this pink bit over here, and I'm going to put that pink bit down there. Okay, so this side over here has moved over there. And then I'm going to draw the orange sides that close up my square. So here is my pink 3, my side over there, that's this side. And now my square has been closed by those orange circle. So now this is what my diagram looks like. Okay, I have got an orange square, which is x by x. Attached to that, I've got a pink bit that's 3 units long. And down here, I've got a pink bit that's also 3 units long. If you look at this orange and pink shape on the screen, it's not a rectangle anymore, and it's also not a square. So now when I want to complete the square, I want to turn this whole thing into a square so that it's x plus 3 units by x plus 3 units. So in order to complete the square, I now am going to add in this block over here. What is the measure of this block? Well, it's got to be 3 units by 3 units, which is 9. Okay, so that's how I have completed the square. So if I end up with x squared plus 6x, in order to complete the square, I am now going to add 9 onto that. And now I've taken something that was rectangular and I've made it into a square. I don't know if that helps or if that has made it worse. Njabulo?
Yeah, ma'am, thank you. I got it now.
Does that make sense to you? Okay, so now it's a square.
Yes,
and that is what you're doing here, but in an algebraic sense. Okay, when you are completing the square, you're taking something that is, let's just go back up here, that is rectangular in shape. Okay, so in shape, so that's the x squared minus 6x, and you are making it into a square by adding the 9. Okay, that's what completing the square means. All right. Okay. So, and the way that you do that is you do it by halving the coefficient of x. So you halve the 6 or the -6 or the +4 or the -4 or whatever it is, and you square that, and then you add it on. Okay, all right. Where were we? Oh, yes. So now that we have completed the square, it's now possible for us to determine the answer to question 5.2. So the coordinates at the center would be +3 and -2, and the length of the radius is going to be √18. All right, Kanisile, I see you've got your hand up. Would you like to ask a question?
Good evening, ma'am.
Good evening.
Ma'am, if it won't be a big problem, can you give us like the breakdown of how this is done in words, so that we have it down to remember?
Okay, so do you want me to write it rather than say it?
Yes, please, ma'am.
Okay, all right. Okay, so then what I would need to do is, okay, so you've got x² plus 6x, all right? So step number 1, all right, is to take half of the coefficient of the x term. So in this case over here, it's half of 6, okay? Then what you're going to do is, once you've worked out what half of the coefficient term is, you're going to square it. You take that value, you take that number, and square it. Okay, so in other words, you're going to multiply it by itself. So you've got half of 6 is 3, and then you take that 3 and you square it and you get 9. And then you add 9 to x² plus 6x plus 9 to make a perfect square trinomial. And what you add to the left-hand side of the equation, you must add to the right-hand side as well. Okay, so balance your equation. By adding 9 to the other side. Okay, so obviously it's not always going to be 9, can you see there? It's going to be whatever number you're working with. Okay, and I mean, it could be a fraction. They could be mean to you and make it a fraction as well. But if you understand the process, then it should be fine. Yes, you're quite right. It would be, neoformalo, it would be 3√2. Okay, so what your calculator would do, you wouldn't get marked down for that. What your calculator would do, your calculator is programmed to do this, right? And that's where the 3√2 comes from. But either form, it doesn't matter. Okay, you're not going to mark you wrong. Is that what you were looking for, Kanisile?
Yes, ma'am. Thank you very much.
It's a pleasure. Have you had an opportunity to get this down?
Yes, ma'am.
Okay, all right. But then at least it's here in words as well for you. So if you want to come back and come and watch the video again at another stage, at least it's there. Okay. All right.
Yeah.
And then the reason that this is here is because there's a question that ties to it later on. So after converting to center radius form, the right-hand side must be greater than 0 for the circle to exist. So in order for it to be a circle, r² has to be greater than 0, but you'll see where that filters into what it is that we're going to do. All right, so now traffic lights, here's an opportunity for you guys to do a question. All right, so I think what we can do is, as far as question 1 is concerned, either do 1.1 or do 1.2. You don't have to do both of them. It's just a little bit of practice with multiplying out, okay? And then you can try question 2. What I really want us to be able to practice is, which answer, Michelle? Where there? So this is the 3√2. Is that it? 5.2. Oh, okay, hang on a second. There. Okay, so the coordinates at the center were 3 and -2, and the radius was √18, or if you prefer to write that as 3√2, it's the same thing. Okay, Michelle? Maybe what I should do is let you guys try one of these and the purple one, and then we'll talk about the answers. I don't know, I just don't want to stop anybody from being able to work ahead if you wanted to, but I don't want you to feel, what's the word, overwhelmed by what's here on the screen. But yes, what I'd like you to do is either 1.1 or 1.2. I'd like you to try question 3, and then I'd like you to try something from question 3. So either something a little bit easier like number 1 or number 2, or if you were feeling brave, then you might want to try something like 3.4. But I'm going to be quiet now. I'm going to let you work, and Nicole and I are here if you need assistance. All right. Okay, off you go, Matrix. Is everything okay, Matrix? Anybody got any questions? Cool, Kumo. Are you, what have you managed to do, Kumo?
Ma'am, I did question 3.4, question 2
Oh,
as well as
good.
1.2.
Oh, good. Well done. That's brilliant. Okay, so we'll go through the answers now. In the meantime, Kumo, if you want to, you're welcome to have a look at question 4 and question 5. These are now sort of slightly more challenging questions once we've sort of got the basics out the way. And then I've also got a couple more questions below that as well. I don't know if we'll get to those, but we'll try. How's everybody else feeling? Have you managed to do questions from 1, 2, and 3? Can we start talking about them? Do you need a couple more minutes? Where are you guys at?
Minutes, ma'am.
A couple more minutes. Okay. All right. No problem. Okay. Have I given you guys enough time to do 1, 2, and 3? Can we go through some answers now? Even if you didn't do everything, it's not the end of the world. Is that cool? Can we start marking? All right, lovely. Well done, Neo. All right, so cool. Thanks, Thelma. Thanks, Bochepo. Thanks, Michelle. All right, so these are the answers that I got. Please, if I've made a mistake, please do let me know. But yeah, I don't know, unless maybe it shouldn't just be my answers. Does somebody want to give us an answer for 1.1?
Ma'am, I could try.
Okay, go for it, Oratilwe. Thank you. What did you get?
So my answer for 1.1 is x squared minus 14x plus y
14x, yes, plus y squared.
plus 20y plus 133 equals 0.
That's exactly what I got as well. Okay, so I'm guessing if we got the same thing, we must be right. Okay, good job. Well done. That's really nice. Well, Chepo, do you want to do the next one? 1.2?
Ma'am,
You don't?
ma'am, I did 1.1. 1. I didn't do
You did
1.2.
1.1 as well. Okay, that's fine. Anybody do 1.2 that wants to share their answer?
Me, ma'am.
Cool. Can you see? Go for it.
So, ma'am, I got x squared
Mm-hmm.
plus 12x
Uh-huh.
plus y squared
Yeah.
minus 16y
Yeah.
minus 124.
Minus 124. Okay, I could have made a mistake. I didn't get minus 124. I got minus 44.
I also got minus 44.
Just I couldn't hear that.
I also got minus 44.
You also got minus 44. Mashay, did you? Okay, and 2 million. Okay, so maybe that was just a little mistake. Can you see it? Tabilan, you also got minus 44. Okay, so did Butle. Okay, so here, what would have happened is that you would have had 36 plus 64. Okay, because you would have added 36. You would have added 64, and then you would have taken away 144. Okay, so I think it's just a little adding mistake that you made.
Oh, okay, ma'am. I just realized my mistake.
Oh, have you? Okay, all right, lovely. All right, as long as you know where you went wrong, then that's great. Okay, guys, that's wonderful. Well done. Perfect. All right, question 2. Is there anybody who wants to volunteer and answer for question 2?
Me, ma'am.
Okay, go for it.
Okay, ma'am. So I first used the distance formula
Mm-hmm.
to get the r, the radius.
Okay.
So I got 5 root 2.
You got 5 root 2 for r. Okay.
Yes, ma'am. And then
All right.
I used the coordinates given to us along with the radius to find the center radius.
Okay.
Center radius form, and I got open bracket x plus 1 close bracket squared plus open bracket y minus 2 close bracket 2, which is equals to 50.
Which is equal to 50. Okay, that is exactly what I got as well. Okay, so I think we must be right. Okay, good job. Well done. That's really nice. Excellent.
And then
I beg your pardon?
Ma'am, the general form.
Yes.
I got x squared plus 2x plus y squared minus 4y minus 45 is equal to 0.
1 is 45 is equal to 0. Okay, because you would have had 1 plus 4 is 5. Yes, that's correct. Absolutely. That's brilliant. Good job. Hey, that's really nice. Well done. Very, very nice. Botshepo, I think you put your hand up at one point. Did you want to ask something, or did you want to say something?
Ma'am, I was about to answer question 2, but it's fine.
Okay, would you like to do one of the questions from question 3?
Yes, ma'am.
Go for it. Which one did you do?
3.1.
3.1. Okay, so what did you get in as the coordinates at the center and the length of the radius for number 1?
Okay, so for ma'am, I got to the equation. It said x minus 2 squared plus y plus 1 squared equals to 20. And so the coordinates are 2 and negative 1. And the radius is square root 20.
That's
I think.
square root. Yeah, absolutely. No, you're quite right. Absolutely. And if you did that on your calculator, you don't have to do it on your calculator. There's nothing wrong with what you've said there. Your calculator would tell you that it is 2 root 5. Okay, but that's 100% perfect. Good job. Well done. Nice. Now, I see there was a question here. Mashay and Boutle, you're both asking, where does the 50 come from? Okay, so the 50 comes from squaring 5 root 2. Okay, so she worked out the length of the radius by using distance formula. So between the center -1 and 2 and the point -2 and -5, she worked out the distance between the two. And then she would have taken that and she would have multiplied it by itself, because remember, this number that sits on the right hand side over there, that represents r squared. So 5√2 times 5√2 is 50. That's where it comes from. Does that make sense?
Yes, ma'am.
Yes? Okay, cool. Buhle, is that better? Yes, absolutely. Okay, so, sorry, my daughter was just saying goodnight to me. Well, she's not going to bed, but she's just, she lives next door, so she's just saying goodbye. Okay, we calculate the radius. Yes, that's quite right. Okay, so that's Nicole that's saying that. Okay, perfect. Good job. Anybody do 3.2 that wants to share the answer?
Me, ma'am.
Okay, go for it.
So, ma'am, the coordinates I got for the center and the length of radius that I got was, the coordinates were -1 and 5.
-1 and 5, okay, and then the length of the radius you got?
√10.
√10, absolutely. I got the same answer, Kanyisile. Okay, good job. That's really nice. Anybody do 3.3? You guys don't have to be shy, even if you don't get it right. Like, we're not here to judge you. No one's going to laugh at you. Anybody do 3.3? Okay, so if you're feeling shy, that's cool. Okay, so the coordinates at the center for this one, in case anyone did do it, were +3 and 0, and the length of the radius was √8. Okay, so this circle was shifted to the right, but it wasn't moved up or down. And then 3.4, who said they did 3.4? Was it you, Michelle? Someone said they did 3.4. Kumo, I think it was you. Okay, Kumo, tell us what you got as your answer, please.
So my radius for 3.4 might be wrong because I wasn't sure whether I was supposed to divide the constant value with 2. But for the center, I got the x value as 1 and the y value as 3/2. And then for my radius, I got the square root of 33/2.
You got the square root of?
33/2.
So like that?
No, ma'am. And the square root is on the 33. And
is it only on the 33? Okay, all right,
yes,
hold on, let me just fix that. Oh, okay, Kumo, hold on 1 second. So you got the square root of 33/2. Okay, I could have made a mistake with this particular question. I got the same coordinates at the center, but for my radius, I didn't get 33/2. I got 23/2.
Ma'am, it might be possible that I might be wrong because remember I said that I didn't divide my constant value by the 2.
Oh, okay, all right. So if you,
Ma'am.
okay, so that's why it would be. Okay, so you have to divide through by the 2. Okay, you can't complete the square if you haven't divided through by the 2. Okay, anyway, that's fine. Okay, Kulani, you also got 23/2 or √23/2. Hey, yeah, me too. All right, so over here, I got √23/2. Oh, that's not what I wanted to do. There we go. That's better. Okay, like that. All right, Kulani, that's great. Well done. Very good.
Ma'am,
Yes, Kanyisile?
I have a question.
Sure.
Ma'am, the hint says that we divide by 2. So would we
Yes.
divide? Would we first take the 5 over the equal sign, or?
Kanyisile, it actually doesn't matter. Let's quickly do that one together, Kanyisile, because I think that's a challenging one, and you've got a fraction in it. Okay, so let me just get it down quickly. Did I divide through? Oh, I divided through by 2 already. Okay, so let me just get it down on the side here. So that's 2x² minus 4x plus 2y squared minus 6y minus 5 minus 6y minus 5 equals 0. Now, I'm glad you asked, Kanyasile. It actually doesn't matter. If you divide through by 2 first, and then take that constant term over to the other side, or if you take the constant term over to the other side first and then divide through by 2, it doesn't matter. Okay, it's not important. Let's say we decide we're going to divide through by 2 first. So that gives us x squared minus 2x plus y squared minus 3y minus 5 over 2 equals 0. So now we've got x squared minus 2x, leave a space, plus y squared minus 3y, leave a space, equals, take this guy over to the other side, he changes his sign and becomes positive 5 over 2. Now we're going to complete the square. So we're going to take half of negative 2, which is negative 1, and we have to square it. So we're going to add 1 here, and we're going to add 1 there. Then we've got to take, now this is the hard part, half of negative 3. Half of negative 3 is negative 3 over 2. And then we've got to square this guy as well. All right, and that gives us 9 over 4. Square the 3, square the 2. So now we're going to add 9 over 4 to the left and to the right. So factorizing our perfect square trinomial now. So this one over here, this gives us x minus 1 squared. And then factorizing our perfect square trinomial over here, this gives us y plus, sorry, not plus, beg your pardon, y minus 3 over 2 squared. And here on the right hand side, you could have done that on your calculator, okay, but it's essentially 10 over 4 plus 4 over 4 plus 9 over 4, which is where the 23 over 4 comes from. Okay, and that's why you would have ended up with the coordinates as the center, like Kumo said, at 1 and 3 over 2, and a radius of, because you see, if you square rooted the whole thing, 23 over 2, like so. Okay.
Okay, thank you, ma'am.
And then
I have another
pleasure.
question.
Okay.
So, ma'am, would there be a question whereby we subtract instead of add? Like, as we say there, half of negative 2 is negative 1. What if we got the answer as a negative and we had to put a negative after the negative 2x? The one in
You know, you'll never do that. So because you see, the thing is that when it comes to the squaring part over here, Kanyisile, whenever you square it, whether it's negative or positive, you're always going to get a positive answer. Okay, so it's always going to be plus and plus and plus and plus in this situation, okay?
Okay, thank you, ma'am.
All right, so because you're squaring it, it will always be a positive. All right. And then I see there was one other question. Bootle, you
Yes.
wanted me to explain 3.1, Bootle?
Yes, Lee, there were a couple of requests for
Oh,
3.1.
sure.
Maybe you
Okay,
could
so a couple of requests for 3.1. All right, not a problem. Okay, so 3.1 is, okay, let me just scooch over to the side here as well. Okay, and just keep it on the screen so that we can just see it. Okay, so here in 3.1 matrix, all right, we've got x squared minus 4x, leave a space, plus y squared plus 2y, leave a space, equals, and take 15 over to the other side, and now it's going to be a positive 15. Then what we've got to do is we've got to work out half of negative 4, which gives us negative 2. And then we've got to take that negative 2 and we've got to square it, and that gives us 4. And that's why we're adding 4 to the left-hand side. And if I add 4 to the left, I must add 4 to the right. Okay, and then to complete the square, with, as far as y is concerned, we're working out half of 2, which is 1. Take 1, square it, we get 1. So now we're going to add 1 to the left and we're going to add 1 to the right. Okay, matrix. And then our perfect square trinomial in terms of x is going to be x minus 2 squared. Our perfect square trinomial in terms of y is going to be y plus 1 squared. And 15 plus 4 plus 1 is where the 20 came from. Okay. Bochepo, you were saying, ma'am, can you please explain how you got the square root 8 in question 3.3? Yes, because in 3.3, I got the radius squared to be 8. So that's why I got root 8 as the answer. Do you want me to quickly do that one as well? Let's just do it down here. Okay, so this one was, it was x squared minus 6x plus y squared. Sorry, I just need to go back and go and look at it. Plus 1 equals 0. Okay, so x squared minus 6x, leave a space. You do not need to complete the square on y squared because it's already a perfect square, isn't it? Okay, so that means that the circle has not been moved up or down. It's still lying along the x-axis. It's just been shifted to the right-hand side in this particular case. So we take the 1 over, that's negative 1. So now I'm going to complete the square for x. So that's half of negative 6 is negative 3. And when I square negative 3, I'm going to end up with 9. So I'm going to add 9 in here, and I'm going to add 9 in there. Okay, and now factorizing my perfect square trinomial in terms of x gives me that guy. And y is already sorted, and negative 1 plus 9 is where the 8 came from. All right, so that's why I said the radius was root 8, even though your calculator would go like that and it would tell you that it's 2 root 2. It's the same thing. Okay.
Thank you, ma'am.
It's a pleasure. Have I answered everybody's questions?
Ma'am.
Yes, can you see that?
Sorry. For this section, analytical geometry, ma'am, how many marks does it contain?
Well, it'll be a different number of marks in your June exam compared to your end of year exam. In the end of year exam, it's generally going to be out of about 40 probably at the most, but almost half of that will be grade 11 analytical geometry. So there'll be 2 questions. There'll be a question on grade 11 analytical geometry, and then there'll be a question on circles. Okay, but you're looking at about 35 to 40 marks out of a 150 mark paper.
Yeah.
Yeah, it's quite a lot, isn't it?
Yes, ma'am, it is.
Yeah. So, but obviously it would be less. I mean, I don't know what they've got planned at your school for June, but normally June exams are not out of 150. So normally you'd write 2 different, a paper 1 and a paper 2. And normally they would be each out of 100. So you'd probably find that analytical geometry in paper 2, I suppose, depending on what because you would have done trig, Euclidean geometry, you probably find that analytical geometry will be out of 25 marks at the most in a 100 mark paper. But yeah, it just depends what your school is choosing to do. Okay.
For these June exams, we're only doing analytical geometry for grade 11, the analytical geometry that we learned last year.
Oh, okay. Okay, so they're only doing that with you. Okay, all right. Is there anybody else? Could you please move the screen to the right-hand side? Sure. Is there anybody else who's also only doing, is that what you wanted to see, Michelle? How far? Is that far enough? Is there anybody else that's only doing grade 11 analytical geometry? in their June exams? If you could just say me, ma'am, in the chat. Anybody else just doing grade 11 analytical geometry in the upcoming June exam? Oh, you still need to do analytical. Okay, Michelle. Anybody else that's already done analytical geometry or is in that position where they're only doing grade 11 analytical geometry? Okay, so Cassandra, you're doing 11 and 12. Thelma, you've done it. Or Chepo, you think so. Okay, Tabaling, thank you. You haven't started analytical yet. Neo Fumalo, 11 and 12. Kumo, same. Thank you, Kashandra. Okay, Mpo. Thank you, Moronkhua. Thanks, Tato. Thanks, Ryle. And Buhle and Njibulo. Thanks, Kulani. Okay, no, that's nice for me to know that because thanks, Buhle. Yeah, I mean, grade 11 analytical geometry is super, super important, and it's not something that I have focused on now, but maybe if I can try and squeeze in a lesson on it or try and sort of include it. Oh, you're done with grade 12, yeah, analytical geometry. Then I would like to see if I can try and do that with you guys because, yeah, the grade 11 stuff can sometimes be a little bit tricky. Yes, Kanisile.
Ma'am, if you had to include the analytical geometry for grade 12, grade 11, can you please focus especially on the inclination part?
Angle of yeah, absolutely. Absolutely.
That would
Absolutely.
be really helpful, ma'am.
Yeah, no, absolutely. Not a problem. Sorry, Laracha. Yes, we've gone completely over time. Of course you guys can. Of course you guys. No, I'm so sorry. Yeah, no, that's fine. Of course you can go. My apologies for taking too long. Oh, just do the poll first, please, please, please.
And this quiz today, everybody.
Oh, yes. Okay, even if you don't do the quiz right now. Thank you. Bye, everyone.
Bye, ma'am. Enjoy the rest of the
day.
evening.
You too. You too. Take care.
Thank you for the lesson, ma'am.
It's a pleasure. Anytime. Yes, Cassandra.
Hi, ma'am. I was just wondering, where can I get your previous lesson? Because it seems like I'm bouncing between two different teachers. So I haven't been seeing a previous lesson.
Okay, so Cassandra, what Toby decided to do is they decided to split the matrix up. All right, so Marilise is doing sort of like a foundational course, and then the one that I'm doing is supposed to be the sort of slightly more advanced one. Okay, so what you will find, Nicole, help me here, is that my previous lesson, it might not be on the website just yet, but it will certainly be uploaded, I would guess, by latest tomorrow. Is that right, Nicole?
That's right, Lee. I'm just finding the link for Cassandra.
Okay, so are you just posting the link into the chat?
Yes.
Oh, you are amazing. Okay, so Nicole's going to post the link into the chat for you, okay, Cassandra, and then you'll be able to just click on that, and then you can go and watch the lesson from Tuesday, okay?
Okay, thank you, ma'am.
It's a pleasure. It's an absolute pleasure.